Hello friends, in this video we're going to look at this Techball radio controlled pinball machine. I got this at the thrift store for $7. It didn't have the radio control, and it turns out it doesn't have anything but an on switch and an off switch. So it isn't really usable as a pinball machine. I've seen a video of this online being played, and honestly it doesn't look like it's any fun. It's supposed to be mounted vertically versus the pinball machine in reality I believe have a 15-degree angle, which is kind of part of the overall concept that makes an actual pinball machine fun. But what I'm hoping to find in this is some nice servos to run these mechanisms, and various lights and switches, electronics, some little speakers. So we should have some fun with this. I'm going to turn it on real quickly to show you what it does just as is. It says high score and 0. That makes sense since it's been on and off. So next we're going to take the back off of this and see what's inside. So here I've got the back off. This is the top area and the bottom area here. Turned it sideways to give a better picture here. The first thing that struck me is these look like really heavy-duty solenoids for just sliding this little plastic thing back and forth. These are the two flippers, and there's some sort of plastic mechanism in there. This is the ball ejector. Normally have a knob on the front of a pinball machine that you pull on to launch the ball. That's kind of spring-loaded, or some are electronic and servo-driven. This appears to be the main board. You've got the cable and auxiliary board for the scoring here. These two little El Cheapo speakers. Actually, there's only one. See, they're already playing games with us. This appears to be the radio antenna, because this wire doesn't go anywhere and it's kind of long. So we'll see if we can take a peek in there. We'll probably have to take that circuit board off. Now I'm not going to try to preserve this in any way because like I said, it's a part piece, and also I don't have the rest of it, and also it isn't any fun to play apparently. Here's a small toy motor type thing. So it'll be pretty easy to get this apart in major pieces. There's probably some plastic mechanisms underneath that go with the flippers, if you remember what those look like. And here you can see this probably pulls really quick to pop the ball up. Here's a couple of other little details: the on-off switch and power connection. These are sensors for what would be the pop bumpers, except they don't pop. Here's another one that probably goes around over different places. Let's see how many this has. Looks like it has 3 pop sensors and maybe 1, 2, 3, 4, 5 lights or so, 6, whatever. Take the screws off here and then we'll see what this board looks like, the main board. So I pulled up the tape in a few places, took out the screws, and let's turn this over and see what we have. So we've got evidently a microcontroller of some kind. Could be like an Arduino or something. If that looks familiar to you, let me know. Tried to look for schematics on this and couldn't find any, but got probably a simple regulator here, or that may be a power transistor. I got 3 power transistors and diodes, which I'm guessing run the 3 servos. Maybe this one runs the motor or something like that, or the, oh, actually that may be the audio amp. Different conditioning over here. This coil suggests that this is the RF input, which I'm going to guess, yep, it's right opposite of what I saw as the antenna earlier. So this may be useful to keep partly as a driver circuit. Maybe I can reverse engineer this and put my own processor in it. I don't know if I'll go that far. So really the goal here is to kind of go ahead and gut this and then see what parts of it we can reuse. Some will go in the junk box in the general sense. In particular, I have a plan for these servo actuators in a future project, and these are kind of expensive individually, like $12 or $15 each depending on the capabilities. So from a bargain standpoint, I got 3 that are very likely good for $8, as well as other little miscellaneous things, toy motor, etc. Here we've got all the pieces spread out and kind of pulled apart and separated into categories. We've got a lot of miscellaneous plastic pieces, lots of screws, tape, our 3 linear actuators. I've got these 2 pulled out. You can see these are in kind of a mirror image situation for the left and right flippers. These are little leaf switches that have 2 switches each for left and right, basically. And over here on the board we've got our 3 probably MOSFET transistors to drive the actuators, microprocessor. This is the RF section with something called super chip. I haven't looked that up. This is an LM386 audio amp, just a very simple self-contained IC with some capacitors. This is a 7805 regulator, which is a 5-volt regulator to run this microprocessor, I assume. We've also got some, these are opto sensors that are, I think, detect when the ball comes back at a certain point in the machine. And so I've decided for this board, there's actually a lot to keep here. I think basically if I pull the microprocessor off, I'll have a lot of good points to drive key places. One of the good things about this board is it's going to have built-in, analog drive circuitry like transistors and capacitors and resistors. So I don't know or care too much about the microprocessor, but we can pull that off and then drive the pins with a different microprocessor or whatever. As another item, it has these little tiny light bulbs. These are the incandescent of the type that you see on model train sets and so on. So there's a lot of neat components here to reuse. Some will go in the junk box like the opto detectors, but got a real good use for these linear actuators. So here I've got the plunger put back into one of the magnetic coils. I've experimented with this a little bit, and I'll show you what it does. Here we've got about 4.4 volts, and it kind of goes down gradually. Let's see where it first begins to move. So that's at about 3 or 4 volts. Now, if we go up to the much higher voltage, the input voltage for this was 22, which I assume is what these actuators are actually supposed to run on normally. Here you can see it does a real solid pop. So using the spring and the lever here, you can, and by adjusting the voltage, you can get different ranges of action on this. So that does it for this video. If you enjoyed the video, please like and subscribe. I'm planning to do more with these actuators in the future. I hope you'll find that interesting. It's been kind of a long-term interest of mine that I never have gotten around to. So thanks for watching, and bye-bye.